1.5 polynomials inequalities. So when we write f of x, we're referring to what value? The y value, exactly. They're somewhat synonymous with each other. It's just different notation thanks to Euler. And then it's on the graph of f of x. All right. And so f of x being greater than 0 means that f of x is what? Above. Above the what axes? The x-axis. All right, so it's up her. And then if f of x is less than 0, that means the graph of f is what? Below the x-axis, so down her. And so let's look at part A. So f of x is equal to 0. So when does this thing cross my x or touch my x-axis? At -3 and -1 and 3. All right, so it touches right there. And so where is f of x greater than 0? So that basically means what? Above the x-axis. So when is it above the x-axis? I'm looking for an interval now. So from when to when? -1 to, oh, sorry, I can't do that. -3 to -1. We're not going to go backwards. In America, we read left to right. And so we go from -3 to -1. Now, why am I using a parenthesis instead of a bracket on this one? Not because it ends, because it's not equal to 0 yet. All right? And so that's why we use a parenthesis and not a bracket. And then, when else is it above the x-axis? From 3 to a positive infinity. All right, so now let's look at part C. This says when f of x is less than or equal to 0. All right? And so this is when it's below my x-axis. So when is it below my x-axis? From -infinity all the way till what? -3. Do I get to include -3 this time? Yes. Why? Because it says or equal to. And the way we denote that is with a bracket. So it's allowed to be equal to -3 on that one. All right, so when else is this below my x-axis? From -1 to 3. Now, do we get to include -1 and 3? Yes, so we use a bracket. All right, pretty good. Cool, we're moving. All right, so now we're going to solve nonlinear inequalities, aka polynomials, and I need a good reader. Oh my goodness, Robert, go.
Solving nonlinear inequalities. Solving f of x equals 0 to create a sign chart with the solutions from step 1, where 3 test values in each interval with saved values, and the interval are blank.
Positive or negative.
4. Interpret the sign chart to answer the given inequalities of the problem. Now, be sure to write your answer in number notation and think about the endpoints.
All right, we're going to think about those endpoints as well. All right, so let's look at example 4. So the first thing we need to do is basically set this equal to 0. Just like we did yesterday when we solved for our roots or x-intercepts or zeros. What do I get when I set x minus 3, that linear factorization equal to 0? What do I get? X equals 3. How about this one? X equals what? -1. How about this one? X equals -4. And this is where I want you to make a little sign, like a little number line. All right. And so what's my left 0? It's at what? What's my furthest left 0? 3, -1, or -4? Furthest left. -4. And then what's my next one? -1 and then 3. All right. And so now this kind of represents like -infinity to -4. This represents like -4 to -1, -1 to 3, 3 to infinity, basically. All right. And so pick something on the interval -infinity to -4. Pick a number. -5. That's what I would pick too. Totally agree. So if I substitute a -5 right here, is that positive or negative? Negative. It's like a -8, right? But I just care about the negative sign. So this is negative. This is what? Negative. This would be what? Negative. So I have a negative times a negative times a negative. What's a negative times a negative times a negative? A negative. So everything left of -4 is negative. We're going to do it again. So now pick something on the interval -4 to -1. -2. I totally agree. So if I substitute a -2 on this one, what do I get? Negative. How about this one? Negative. How about this one? So now I have a negative times a positive. Well, what's a negative times a positive? A positive. So on that interval, I have a positive. All right, so pick something between -1 and 3. 2. I disagree with you. Whenever I can use 0, you can use 2 if you want. But whenever I can use 0, I'm going to use it because I'm not very smart. All right, and so I'm gonna. If you want to use 2, we can use 2. It works the same way, but I'm gonna choose 0 whenever possible. All right, and so which one are we choosing? 0 or 2?
0.
Oh, okay. So if I substitute in 0, what do I get? Negative and positive. So what's a negative, positive, positive? That's a negative. All right, something more than 3, like what? 4 sounds great. And so now this would be what? Positive, this would be, how about that one? So what do we get there? A positive. So now, after I make my little sign chart, I'm going to figure out what I'm looking for. And what I'm looking for here is when it's greater than 0. So what parts do I care about on this little sign chart? When things are what? Positive. And so when are things positive? From -4 to what? -1. Do I include -4 and -1? No. Why not? Because it's not equal to. It's just greater than. If it said greater than or equal to, then I would have what on them? Then I would have brackets. All right? And then, when else am I positive? When is it greater than 0? From 3 to positive infinity. All right? We see how we did that? Cool. All right, let's look at example 5 now. So on this one, when I set this linear factorization equal to 0, I get x equals what? -2, and x equals 5. All right? And so now let's make my little number line. And so I got -2 and 5 going on. So pick something left of -2. -3, totally agree. Now, when I have something like this for like a squared or a 4th power or something, what is this portion always going to be? That part's always going to be positive. So in my head, I usually don't substitute anything in here because I know that part's going to be what? Positive. Does everybody follow me on this? So I kind of like just say, okay, that's part positive, then I'm just dealing with this part. So if I substitute in -3, what's this part? Okay, -8, which makes it what? Negative. All right, so now I have a negative. And then if I substitute in something between -2 and 5, let's see if we learn something. I'm picking 0. I totally agree, Robert. All right, and so now I end up getting a positive times a what? A negative, which is what? Negative. Substitute in something more than 5, so like what? 6. So this part is going to be positive. This part's going to be positive still. This part's going to be what? Positive. So a positive times a positive is going to be what? A positive. All right. And so now let's look at what the question's asking. And so it's asking, when is it less than or equal to 0? So when is it less than or equal to 0? So like negative and including 0. Negative infinity till what? Just to 5. And it includes it. All right? Because can it be 0? Yes, and -2, it is 0. All right? And so it actually gets to include this -2 and this 5. All right? Just for side note, this is like part 2. All right? So on this one, let's say this x plus 2 squared times x minus 5 is just less than 0. I want to show you the difference between them. All right? So it's the same little sign chart, but it's going to be a totally different answer. Not totally, but it's going to be a different answer. So now, can it include 0? No. And so now, it would be from what? Negative infinity till what? -2. And then -2 to 5. Because now it can't include -2, nor can it include 5. All right? But these are still negative intervals. Okay? All right. Let's move. All right, so now we're going to determine the degree of a polynomial. We've already kind of done this before, and I need another good reader. Lucas is going to read.
Determining the degree of a polynomial given a table of values. If given a table of values with equal width input intervals, we can determine the degree of a polynomial by examining successive differences in the output values. The number of successive differences needed for the differences to be constant is equal to the degree n of the polynomial.
All right, fantastic. So we've basically done this before. However, if our inputs have equal widths, we don't have to worry about like finding the average rate of change like we didn't do before. Sometimes we don't need to. And so if you look here, we're just trying to find my common differences. Okay, we've done this before. When have we done this before? Finding if the function is what? Constant or linear. Okay, sorry. Linear or quadratic. That's what we tried to find. All right. And so let's do it again. So -2 to -3 is what? -1. How about -3 to -1? +2. And then -1 to 4. 5. And then 4 to 12. 8. So is it a linear function? No. Let's do it again. So now what's my difference? 3. Now what's my difference? 3. Now what's my difference? 3. So what degree is this? This is a degree of 2. It's known as a quadratic. So my second differences are constant, also known as my average rate of changes are what? Linear.
And the degrees too, because I think there's like two things that are different.
Because there's my second difference.
Yeah.
Yep. All right, let's do it again. So again, we have equal widths for our inputs. So now we can just work with our outputs. So -2 to 0, +2, 0 to 10. How about the next one? Michael Jordan. Good job. All right, and so now, is it a linear? No, so let's do it again. And so now, 2 to 10, 8, then, is it a quadratic? Is it a degree of 2? No, let's do it again. So now, -1, and then -1. So what did we know? It's a degree of 3, also known as a cubic. All right, pretty good? Cool. Let's talk about even and odd functions. Okay, this is where you might struggle slightly. All right, not a lot, but maybe a little. All right, so an even function, I want you to take note. An even function is symmetric over the y-axis. All right, and so what happens mathematically is I change my x and I still get the same output. Okay, so it's when I change my x and it's the same as where we started. All right, and I think looking at ordered pairs, it's the easiest way. So I covered my half of it up. So if I look at -1, -1, if I look at this ordered pair right here, what would change, my x or my y? What did I substitute in? I changed my what? My x. It's f of -x. So I changed my x, so my other ordered pair will be what? 1, -1. And so now it's going to go to like 1, -1 because it just switched its x. All right, it kept its y, it changed its x. So now if I look at like this portion down here, that ordered pair would end up being -2, -3. However, for an even function, it changes its what? Its x, and it keeps its same y. And so my x will now be what? 2, -3. And so that's why it's symmetrical about the y-axis. And if you kind of think of it like up here, you'd have like -3, 3. Now it would kind of go to 3, 3. All right, do you see how it changed its x, but it kept its y? All right. Now for an odd function, I personally don't like thinking of it like this, but an odd this part is. An odd function is symmetric about the origin. Totally good. However, I don't like to think of it this way. I like to think of it as g of x is equal to negative g of negative x. That's the way I want you to think about it. And so what I mean by that is it changes both the x and the y. That's something you want to write down. And so to change its x, this is the input value, all right? So you change its x to negative x. If you change its y, you change out every sign, all right? So that's how you can kind of think of an odd function. So for instance, if I have this as an ordered pair, let's going to say it's like negative 2, 2-ish. To have its odd function, I would change both the x and the y. And so the x would now be 2, and the y would now be what? Negative 2. And so now it would kind of like do that. And then like, let's say we have, I don't know, that point right there. So that's like, what is that? Like negative 3.5, comma, negative 2. And so if it's the odd function, it would be what? 3.5, comma, 2. It would change both of them. All right. And so then we would kind of work like that. All right. So that's symmetric about the origin. All right. So to be an even, you change its what? X. To be an odd, you change both. All right. So let's do it algebraically. So here we go. So I have this function. And so to check for even, I'm going to change its x to negative x. So now I have 2 times negative x to the 4th power minus negative x squared plus 5. If I have 2 times negative x to the power of 4, that's really just what? 2x to the power of 4. The negative sign goes away because it's an even power. And then I have minus. Now I have negative x squared. And so what's the negative x quantity squared do? It just becomes x squared. And then I have plus 5 still. Is that the same as the original? Yes, it is. So it is an even function. So it changed its x, but it's the same as my original function. So that's an even function. And graphically, that would be symmetric about the y-axis. All right, let's look at this next one. So now I have x cubed plus 3x minus 1. So let's check for even. So to check for even, we're going to take negative x and substitute it in for x. So now I have negative x quantity cubed plus 3 times negative x minus 1. All right, so if I have a negative x cubed, what's that going to be? Negative x cubed. The negative gets to come out. And then if I have 3 times negative x, what's that become? Negative 3x. And then I still have minus 1. So is that the same as the original? No. So is it an even function? No, it's not even. So now we're going to check to see if it's odd. All right. And so to change its odd, the way that I like to do it is if you look here, if you have negative g of negative x, didn't we just do this like g of negative x thing? We did that part. So what I need to do is I need to distribute a negative to what I just did. So here's my function. Now I'm going to distribute a negative. So now I'm going to change every sign. So if I distribute the negative there, it's now a what? A positive x cubed, and then what? Positive 3x, and then what? Positive 1. Is this the same as the original? No. So is it odd? No. So it's not even or odd, so it's neither. All right. Now I want to try to break this down for you as best as possible. When I have 1 or any constant, this is really an x to the power of what? It's an x to the power of what here? 0. Okay? And so if I don't have a variable, it's a power of what? 0, which is basically even. So if you have all even powers, it's going to be even. If you have all odd powers, if you look here, this is a cube, right? That's odd. This is just an x to the power of 1, right? That's odd. So this function right here is odd. However, if you look at the one that we just did, you have an odd power, and then what? A constant. So is the constant an odd power? No. And so that's what broke that one. That's what made that not odd. All right. All right, let's look at part C. Graphically, you guys can see these really well. So is part C even, odd, or neither? This is odd, for sure. All right. It's symmetrical about the origin. So if you kind of look at an ordered pair of like, I don't know, right here, like -1, 3, then if you switch them both, it'd be +1, -3. All right. It switched both the x's and the y's. All right. Is part D even, odd, or neither? Neither. All right. It's not symmetrical about either. All right. It's kind of shifted. If you had it like right there, then it would be what? Then it would be even, but it's not. All right. It's kind of shifted over. All right.